Look at this archival photo. Medical workers in white coats are carefully weighing traditional herbs in front of a massive wall of wooden apothecary drawers. For centuries, the Ganoderma lucidum, better known as the reishi mushroom, held a revered spot in drawers exactly like these, prescribed by herbalists as an ancient elixir of longevity. Modern skincare brands attempt to capture that ancient prestige. They buy raw mushrooms, grind them into a powder, and add microscopic fractions of them to commercial lotions. In the industry, this is called fairy dusting, adding just enough of a natural ingredient to put it on the label, but nowhere near the concentration required to actually work. The epidermal barrier is designed to keep foreign matter out. Applying raw, ground-up mushroom means applying compounds physically too large and biochemically inactive. They just sit on the skin surface, unable to penetrate or alter tissue. To harness the mushroom's dermatological potential, scientists have to intervene long before it ever reaches a jar of night cream. By biohacking the cultivation process and locking into the dirt itself, researchers have proven that creating clinical-grade skincare depends on engineering the organism from the substrate up. In mycological research, a mushroom is only as potent as the food it eats. The potency of a Ganoderma harvest is determined by its growth medium. By formulating a specific base of hardwood sawdust enriched with rice bran, scientists create the exact nutritional profile the fungus needs to build therapeutic molecules. During the early primordial formation phase, cultivators induce environmental stress. They deliberately restrict air exchange and manipulate ambient carbon dioxide levels around the growing fungi. This flowchart tracks how the organism reacts to that stress. Instead of normal growth, the suffocating environment triggers a biological defense mechanism. The stressed pathway outputs a denser cluster of complex molecular structures, forcing the fungus to overproduce highly oxygenated healing compounds known as triterpenoids. Cultivators monitor the fungi closely, waiting for the precise moment of spore release. Harvesting at this exact biological window ensures the maximum possible accumulation of these bioactive compounds. Extracting them presents a significant biological obstacle. The most potent lipids and triterpenes are locked inside microscopic spores, encased in a tough, double-walled chitin matrix. You cannot dissolve this chitin shell gently. To release the hydrophobic compounds for skincare formulations, these spores must be mechanically shattered in a violent cell wall breaking process. Combining precise environmental starvation with a destructive mechanical extraction transforms a simple forest fungus into a concentrated source of clinical-grade bioactives. This animated cross-section shows the human cutaneous tissue. It acts as a multi-layered battleground, facing 4 distinct biochemical threats that require a coordinated response. At the surface pigment zone, UV exposure causes hyperpigmentation. Here, the extracted ganoderic acids hunt down and block an enzyme called tyrosinase, the specific catalyst responsible for overproducing melanin. By jamming this enzymatic cascade, the extracts halt the production of dark pigment and fade existing sunspots. In the deep collagen matrix, UV radiation creates reactive oxygen species that tear through the tissue. Fungal polyphenols flood this area to act as radical scavengers, intercepting and neutralizing the destructive molecules before they can trigger the enzymes that eat away structural collagen. For conditions like eczema or severe redness, extracted peptidoglycans enter the tissue and actively suppress inflammatory signaling pathways. They shut down the release of pro-inflammatory cytokines, cooling the tissue and reducing swelling. Finally, at the uppermost surface layer, high-weight fungal glucans spread across the top of the epidermis to form a biomimetic film. This physical shield binds water to the stratum corneum, bouncing escaping moisture back into the tissue to repair the damaged barrier. These processed extracts interact with the entire cutaneous matrix, addressing multiple distinct damage zones in a single application. Because this complex bioengineered matrix targets so many different biological mechanisms at once, treating the skin effectively requires a dual-route application strategy. The first route is outside-in. By applying high-concentration serums topically, free triterpenes penetrate the epidermis directly, the optimal delivery method for localized targeted issues, like fading a specific sunspot or smoothing out fine lines around the eyes. This split-screen diagram highlights the second route, inside-out. While the left side shows topical absorption, The right side traces the path of oral supplementation. Digesting the extract works via the gut-skin axis, balancing the internal microbiome to regulate immune responses and clear chronic, full-body inflammation. The resulting clinical outcomes, the fading pigment, the protected collagen, the restored moisture barrier, are a direct consequence of the carbon dioxide levels and specific substrate used during the initial cultivation phase. Clinical skincare at this level requires engineering nature from the substrate up.